So we're going to take a moment to talk about the axis of symmetry. So we are looking at a parabola on the screen here. It's been divided into two parts, and we have that straight up and down line. And the first thing I'm going to do is I'm going to go ahead and get the axis of symmetry written down. That's our vocabulary word, axis of symmetry. The axis of symmetry is that straight up and down red line. And the axis of symmetry for this parabola is x is equal to 1. All vertical lines are written as x equals a number, and this one is no exception. The x equals 1 comes from our vertex at 1, -2 on our parabola. The axis of symmetry always cuts through our vertex. And the axis of symmetry, the reason it's called the axis of symmetry is because it divides our parabola into two symmetrical parts. Two parts that if you were to mirror them onto each other would overlap perfectly. So if you can imagine flipping that green part onto the blue part, they would overlap exactly. So that's what our axis of symmetry means. Among other things that's related to, you can see that all of our points on the axis of symmetry, every single point is the same distance apart from each side of the graph to the axis of symmetry. So if we look right here, this point right here on the blue part is 1 unit away from the axis of symmetry. This is 2, this is 1 right here. And this point over here on the green one, which is on the same horizontal level, is also 1 unit away from the axis of symmetry. And this is essentially what allows us to use some of the patterns we've seen earlier in order to construct the graphs of our parabolas, is because every single point in a parabola on the other side of the axis of symmetry has another one the same distance apart, just in the opposite direction. And this symmetry of the parabola can make it a lot easier to graph than some of the other functions we'll eventually be working with. So it's very useful in that respect. If we know our axis of symmetry, even if we don't yet know what our vertex is, it gives us a quick shortcut to find it, because the axis of symmetry, that x is the x value of our vertex. So if we need to figure out what our vertex is and we know our axis of symmetry, we can plug in the x in the axis of symmetry and then solve and find the y value of our vertex, which in this example would be a -2, although I won't go through the actual solving portion. I'll leave that to you. In addition to that, if you know what the vertex is, you also get the axis of symmetry for free, because the axis of symmetry is just x equals the x value of the vertex, which in this example is 1. So our axis of symmetry is x equals -1. The other thing that's quite useful about the axis of symmetry is the axis of symmetry also divides your parabola into portions which show where it is increasing and decreasing. On one side of the axis of symmetry, it's always increasing, and on the other side, it's always decreasing. Which side that'll be the case will depend on in which direction our graph opens. In this example, the parabola is decreasing in the green portion and increasing in the blue portion. And if you imagine a point going up and down this graph, in fact, you don't even have to imagine, I can just drag the point on the green portion. When we're talking about increasing versus decreasing, we're talking about that y value. So the y value right now is 1.83. As I drag from left to right, the y value slowly decreases. And then it gets into the negatives. And then we come all the way down here to our vertex, and it reaches its lowest point, a y value of -2. And then if we go ahead and get on the blue portion of this, it will start at -2 and it start increasing from -2, -1.5, -1, 0, and then all the way up and off forever. So in this one, the blue portion increases, the green portion decreases, and the axis of symmetry perfectly divides it into those two portions. So that's what the axis of symmetry does. It provides us a lot of useful information about our parabola. It allows us to construct them a lot easier. But finding it, if you know the vertex, is pretty straightforward. And you're going to want to make sure that you're thinking about the axis of symmetry when you're graphing, and also considering, if I'm given the axis of symmetry, what information do I know about increasing and decreasing? What information do I know about the vertex?